Wet filament leads to printing errors. I will show you how to prevent, identify and dry wet filament. Some filaments such as PLA and ABS only absorb moisture from the air slowly and in small quantities. If they are stored open, they are saturated after a few days, which means that they will not absorb any more moisture. Filaments such as PETG on the other hand absorb moisture more quickly and in larger quantities. Here, saturation occurs within a few days or even within a day. Very hygroscopic filaments such as nylon absorb moisture extremely quickly and in large quantities. Here, saturation can occur after just a few hours. The more moisture a filament contains, the more printing errors can occur. It is therefore best to prevent the filament from absorbing moisture in the first place. The right storage method for preventing wet filament depends on how hygroscopic the filament is. The first rule is to keep the filament in the vacuum packaging in which it was delivered until it is used for the first time. Filaments that do not absorb moisture as quickly like PLA or ABS do not necessarily need to be stored dry after the first use, as long as they are used up within a few weeks. It is sufficient to protect them from direct sunlight. Only when they are stored for longer should they also be protected from other environmental factors. The best and most cost-effective method for storing filament safely and dryly is to use silica gel in an airtight container. This can be a plastic box with a seal or a vacuum bag, for example. The silica gel absorbs the humidity in this container and thus protects the filament from moisture. All other filaments should be stored dry at all times as long as they are not being printed. Some filaments such as nylon or PVA should even be kept dry during printing, especially if the humidity is very high and/or the printing project takes several hours. But how do you notice that the filament is wet and that printing errors may be due to this? What are the symptoms of moisture in the filament and when should you start active drying? Regardless of which filament you are working with, there are a few symptoms that can indicate moisture or too much moisture in the filament. The first symptom is stringing, a printing error that often indicates too much moisture in the filament. With filaments that are highly hygroscopic, such as PETG or nylon, other symptoms can occur such as irregular layers. In extreme cases with nylon, PVA or other highly hygroscopic filaments, moisture is already visible when the filament is extruded from the nozzle. This can result in hissing noises, vapor and bubbling. However, what you should do next is only clear in the case of serious symptoms. If the filament steams or forms bubbles during extrusion, it is clearly too moist and needs to be dried. But if you only observe stringing, moisture can be a possible cause, but there are also many other reasons that can lead to stringing. The priority for drying the filament varies depending on the filament used. With PLA and ABS, other measures to prevent stringing should be taken first, such as calibrating the retraction or the printing temperature. Drying has a lower priority here. However, the more hygroscopic the filament is, the more likely it is that moisture in the filament is the cause of stringing, making drying a higher priority. If moisture in the filament is not the cause of your printing errors, or you generally want to get perfect results every time as quickly and easily as possible, you should take a look at my 3D printing course. In over 60 video lessons, you'll learn everything you need to know about 3D printing. You can find the link in the video description and in the pinned comment. The simplest but least effective method of drying wet filament is passive drying with silica gel in an airtight container. In other words, just like storage. With this method, you can only extract small amounts of moisture from the filament over a certain period of time. If you suspect that your PLA or ABS may be wet, you should first dry it with silica gel for a few days before resorting to an active drying method and possibly wasting money. For very wet filament, however, active drying methods are necessary to avoid printing errors. The best active methods are either a normal oven or a specialized filament dryer. The problem with a kitchen oven is that you can never be completely sure whether there will be a temperature overshoot during heating or whether the temperature is generally very inaccurate. If this is the case, it can quickly happen that your filament melts inside. So wait some time until the temperature has stabilized before you put the filament in. Apart from that, this method is a good improvised way to get quick results. Here are my recommended temperatures and time periods for drying different filaments in a kitchen oven. You can dry wet filament faster, safer and better with the filament dryer. As an example, I have here the NT1 filament dryer from Fixdry. In this filament dryer you can put 2 spools at once. Such filament dryers are specifically designed for this purpose and can dry the filament fast and reliable. Temperature overshoots, which can occur in an oven, also do not occur here. With the NT1 filament dryer you can set the temperature to up to 70 degrees Celsius and a maximum drying time of 48 hours. This means that every type of filament can be used in here. If you are interested in this filament dryer, you will find the link to the official store in the video description and in the pinned comment as well. To demonstrate the drying effect, I stored PETG filament in this airtight container with water in my attic for a few weeks. Now in summer the temperature there is regularly over 30 degrees Celsius and in the container with the water it should be like a steam sauna. The filament is therefore very wet and this test print proves it. So let's put it in the filament dryer. And now we test whether the result has improved. And as expected, there are no more symptoms of wet filament. That's exactly how it should be. And to ensure that this is the same for the next print and we don't have to actively dry it beforehand, now we are testing whether the storage solution I have shown is effective enough to keep the filament dry. So I remove the filament again and store it in an airtight container with silica gel. And after a week we test the print results again. And as hoped, the result is perfect again. To summarize, you can use the slightly hygroscopic filaments like PLA, ABS and PP for a few weeks without special storage or drying. After that, you should store them in a dry place. Active drying is not necessary for these filaments in most cases and is only recommended if you have ruled out all other causes of printing errors. All other filaments must be stored dry immediately after each use. The highly hygroscopic filaments PETG, ASA, TPU and PC should also be kept dry during printing in very humid ambient conditions or for print jobs that last longer than a few hours. Active drying is only necessary if printing errors occur, but then as one of the first measures. The extremely hygroscopic filaments nylon, HIPS, PVA and PEEK should even be actively dried during printing in order to avoid printing errors. If you are only using HIPS or PVA as a support material, this is not absolutely necessary.